We're going to evaluate this integral here, and normally what we do is a u substitution, take u to be everything under the square root sign, and everything falls apart really nicely. It's like putting a roast beef in the slow cooker for 8 hours, right? Super easy. We're going to actually do this a slightly more complicated way because I want to show the trig substitution for this type of a problem. And so we're going to evaluate this using a trig sub. So we're going to start off by reminding ourselves for trig subs what we would use. And there are 3 basic ones. The one that we're going to see today, if you see the square root of x squared minus a squared, you are going to use, for a u sub, x is equal to a times secant of theta. And the identity that you will also be using as a very nice tool is going to be the identity, and I'm going to write out first the one that you will normally see it written as, and there's some squared in there. 1 plus tangent squared is equal to secant squared. In this particular case, we're going to see that written slightly differently. We'll see secant squared theta minus 1 is equal tangent squared theta. So we're just rearranging that equation a little bit, and that's how it's going to be used. There are 3 different basic trig subs for integration, and this is one of them. The other 2 work very, very similarly. Now, let's start off with the fact that when we're looking at this, one of the things we want to know is, what is this a value that we're going to be working with in this case? If we look up at our equation that we have here, we have the number 7. That tells us in our instance, a squared is equal to 7, which tells us that our a is going to be equal to the square root of 7. So it's just slightly different in that way. All right, let's use our trig sub. So remember, we're going to be using this one right here, and we're going to take our x is equal to the square root of 7 times secant of theta. So let's do that right now. We have x is equal to the square root, secant of theta. When we take the derivative of that, we get square root of 7 secant theta tangent theta d theta. And normally, once we do this, we start substituting things or trying to solve for things. We're actually going to do a little aside before we put anything in. And this is what you want to do for all your trig substitutions for integrals. You want to do the aside. And what we're going to do is we're going to figure out what that denominator looks like before we do any substitution at all. And it's going to make our lives a lot easier. So let's start off with square root of x squared minus 7. When we put our substitution in there, that is going to be square root of 7 times secant theta, and we are squaring that whole thing, minus 7, right, which is equal to the square root, if we distribute that squared to the secant and the square root of 7, that is going to give us a 7, because squared a square root, they're going to cancel each other out. Secant squared minus 7. And normally what is going to happen is you'll see there's a 7 in both parts here, and so we're just going to rip that 7 all the way out. There we go. Now we have 7 times secant squared minus 1. And this is where we're going to use that nice little identity. And in general, for any trig problem, this is exactly where you're going to put that identity. We know that is equal to tangent squared of theta. So we're going to pop that in there, and we're going to have square root 7 tangent squared theta. We can distribute that square root now because we have a 7 times. When you are multiplying two things, you can distribute the square root. And square root of something that's squared, those are going to cancel out. So we get square root of 7 tangent of theta. So in that denominator, instead of square root of x squared minus 7, we're just going to write square root of 7 tangent theta. And it's going to make our lives a lot easier. So the fact that we wrote this out beforehand means that we don't have to write it out while we're writing out an integral and all that extra crud in there. So it's going to make our lives a lot better. All right, we saw that our denominator was just a square root tangent of theta. Our numerator, that x value, is going to be square root of 7 secant theta. And our dx is square root of 7 secant theta. Oh, I'm not going to have enough space. I'm going to move this down a little bit. Let's do that. There we go. Tangent of theta d theta. We're going to cancel a bunch of stuff out. Our square root of 7's, 2 of those are going to cancel out. And our tangents are also going to cancel. So what survives is a square root, 1 copy of square root of 7, and 2 copies of secant of theta. So this is going to give us the integral of square root of 7 secant squared theta d theta. And we know how to integrate that. The antiderivative of secant squared theta is tangent of theta. And of course, because it's an indefinite integral, we'll tack on the plus c. Now, here's the issue, is we need to get this back into x's. So we need x's to be put back in there. To do that, we're going to have to figure out what tangent of theta is equal to in terms of x's. And this is the second tricky part for any sort of trig in substitution that you're working with. And we're going to go back to what we originally had, what we were originally working with. We knew that x was set equal to square root of 7 secant theta. We're going to rewrite that a little bit. We're going to rewrite that as secant theta is equal to x divided by the square root of 7. That looks a little bit better. And we are actually going to pull in, well, it is a trig substitution, so we will pull in a triangle. We're going to put a little theta in here. Secant of theta is the same thing as 1 over cosine of theta, and I'm writing it this way because most students don't memorize what secant theta is in terms of our triangle, and I don't either. There's no point. Those brain cells are better used for other things. But cosine of theta, that is one that we should memorize, and that one is adjacent over hypotenuse. And since we have a 1 divided by a fraction, we can flip our fraction and get our solution there. So the top part, our x, is our hypotenuse. So let's pop our x up there. The denominator, our square root of 7, is going to be our adjacent piece. So that's square root of 7 right there. The third part of your triangle, we're wondering, what does that look like? You can go through and use Pythagorean's theorem, or handy dandy, your third part of your triangle will always look like the thing that you were working with in that first aside, that square root of x squared minus 7. So you actually don't really even need to go through the motions. That's always what it's going to be when you're doing a trig substitution. All right, so let's go back to, we need to know what tangent of theta is. And we know tangent is opposite over adjacent. So this is going to be the square root of x squared minus 7, our opposite side, over our adjacent side, square root of 7. All right, one last step. We had our integral, I'll just rewrite that quickly. Our original integral dx, we did a bunch of stuff. We got square root of 7 tangent theta plus c. And we know that we can replace that tangent of theta with a fraction, square root of 7 plus c. And we can now cancel those square root of 7s. And that leaves us with the square root of x squared minus 7 plus c. So there is our solution to our nice trig substitution. Thank you for listening.